All right. We can breathe for a second. I'm going to start a new topic because we have 10 minutes. All right. Now, what I am supposed to cover are insertion sort, selection sort, merge sort, quick sort. At least I'm supposed to cover some of them. I don't know about doing all 4 of them. How many of them have you heard before? You did merge sort with me, right? Do you know, anybody not know insertion sort? All right. All right, good. Well, we're going to cover it. All right. And we're going to cover it so fast. And the reason we can cover it so fast is because we're using loop invariants, and I'm not doing code and the details of the code. All right. All right. So martial arts says do simple things. Pay attention. Wipe on, wipe off. Right. Here's the code. Do you like reading code? He likes reading code. I don't like reading code. All right. So we're going to go to this high level. All right. So we're going to do it proof by pictures. Here's the precondition as I have a set of numbers. Postcondition is they're sorted, same numbers, right? So, right now in the middle, where am I? What do I know in the middle? Maybe I know some weird facts, right? What am I going to do with these weird facts? I don't know. That's too weird. So instead, I'm going to design a loop invariant. What do I want to be true in the middle? Well, my whole job is to get all these numbers sorted. Well, when I'm halfway done, I've sorted some of them, right? All right, so what's my loop invariant? There it is. I got some numbers. Every number appears exactly once. Some numbers are over here sorted. The rest I haven't looked at yet, right? Everybody got a good loop invariant? You can see what's nice about this loop invariant. It's kind of halfway between this and that, right? In fact, you can twerk it. If you put no numbers over here, you got this picture. If you put no numbers over here, you got that picture, right? It's a really nice, it flows from one to the other. Right? Everybody good? All right. Right. So this just says, I haven't told you how many numbers are over here, and I haven't told you which numbers are over here, right? And why have I not told you that? Well, I haven't told you how many because I want it to flow, and I haven't told you which because I want to give as much flexibility to the coder as possible, right? This is just saying some of them are over there, right? And we're not going to actually implement this, right? We're not going to code it up, right? So what's our measure of progress? How much work have we done so far, right? It could be how many you've sorted, or it could be how many you don't sort, right? You can either have your measure go down or your measure go up, right? If it's how much work I have left to do, it should go down. If it's how much work I've done, it should go up. Doesn't matter, right? So which do we do here, right? I guess we were talking about it coming down, right? All right, so how do I define a step? I'm here. I need to make progress. So I have to take a number out of the right, right? And what do I do with it? Exactly. It's called insertion sort. I take some number, doesn't matter which, and I scan along and I insert it, right? It's called insertion sort. And, right, that's what we do. And you keep doing it, right? And so here, in fact, one page is the whole algorithm, right? You got the precondition is true. How do you establish the loop invariant? Well, you could say, you could put one number over there one numbers are automatically sorted. You could put 0 numbers over there. 0 numbers are automatically sorted, right? And then you keep doing this. And when do you exit? When there are no numbers over there. And then how do you get from there to here? Well, you got to throw away this little piece, right? Whatever data structure that was goes away. Right? Everybody got this? Yeah, yeah. Very good implementation question, right? I threw that under the rug, right? So if I'm taking 62 and I'm inserting it, let's go back here, right? How do I know where to put it? And this is beyond, we haven't learned yet binary search, but you could do binary searches much faster to find out where it goes. Now you know where to put it, but how do you get it in there? Well, if it's a linked list, well, you can't do binary search, right? And if it's an array, you got to shift everybody over, right? And if you got to shift everybody over anyway, you might as well shift as you look at them, right? So the algorithm would be, you look at the 88, it's too small, so you move it over one, right? Then you look at the 52, if it was too small, if it was too big, you'd move it over one, but it's not, so you plop in the, right? So you do this. So. Everybody good? Yep. So I like pictures. You have a pencil, you can draw pictures, you can write things in math, you can say, right? I mean, in adding up 1 squared plus 2 squared, right? We laid out how to write it up. So those are the things that you would do in a 3101 test. In fact, later in these slides, we're going to look at an exam question that I gave in this course a couple years ago. And the truth is, I think everybody bombed it. All right? So let's not bomb them. All right? Right? So how do you present, how am I saying, right? What's the mantra that we're saying here? Right? If you were talking to Jackie, his mantra is give me code. Right? And if you're talking to Jeff's, what his mantra is, give me a loop invariant, give me pictures and describe the loop invariant. Tell me how you're going to establish the loop invariant from the preconditions. Tell me how you maintain the loop invariant while making progress. And tell me how from the loop invariant in the exit condition, you get the post condition, right? So that's my mantra. And then what are you going to have on the test? Is some merging of those, right? Yeah. So I kind of said, how do you give the loop invariant? Well, you can give it in as a picture. You can give it as text. You're better off giving it as many modes as possible because your goal is to make the TA happy, and you're not sure what's going to make the TA happy, right? So you could draw a picture like this, but you should include in there, right here, what am I doing up here? Right, I'm establishing the loop invariant, right? What am I doing here? I'm maintaining the loop invariant. Maybe you can put in a little couple words about how to do that. right? And I probably won't be marking things, but when I'm marking, I'm really lazy. And if I see on your page the perfect picture, and I've marked a dozen tests completely wrong, or, and I've given them 0, and suddenly I see the perfect picture, I sometimes just give you perfect and don't even read a word you wrote, right? All right, people are moving, so we're probably done. Everybody good? All right, we'll see you on Wednesday. If you read this paragraph on your own, you can see how what it's doing is establishing the loop invariant, maintaining the loop invariant, and getting the postcondition.
That there was like a little bit like maybe like different in terms of like the Jackie like on the code and on the so given that we're probably gonna have the same TA marking the test where we're gonna have our TA for like physics and marking the like restrictions paper and like
So for the midterms, so the written, there's 2 code tests, which I have nothing to do with. And then there's 1 written test, which I'm going to write 100% myself. My TAs will mark. And then there'll be an exam, which will be some of all 3 of us.
but like the TA is gonna like mark exactly the same or like because sometimes
I've only coordinated once before in my life, in the last while, and that was I was doing 1019s. And what we did there is the exam was the same for every section, but I had my own solution set, and I had my own TAs. So the TAs were marking using my solution set.
Yeah, that actually makes sense. Yeah, because I was like wondering if that's kind of potentially the case for it.
Yeah. So I think sounds reasonable, right?
Yeah.
Right? I mean, even for this practice test, right?
Yeah,
I read Jackie's practice test, and it's not the way I would do it. And I said in class once how I would do it different, and we could talk about that again. I could repeat that.